My name is Marc Cram. I'm the Director of Sales for the Server Technology. We are a brand of Legrand. We are based in Reno, Nevada. And I want to thank DCD, before I get too far along here, for putting together the show. It's been a good turnout for everybody. We appreciate the hard work for the women and men that have pulled the unit together and gotten it off the floor. So today's topic I'll be addressing is powering the edge. I'm going to cover 15 slides. I've got about 20 minutes of material. I'm going to talk fairly quickly, but if you have a question or a comment, please interrupt. I'm all about that. I'd rather have a conversation than a lecture. Okay, I don't know about you guys, but it's been a long couple of days, and New York is tiring. So what I hope to cover is the why edge, where edge, and what you need to look out for on the edge in 15 slides. You think I can get away with that? So, all right. So I grew up in the 70s and early 80s. Powering the edge in my lifetime meant a pint of Guinness Stout for U2, right? The guy that was the lead guitar player for a very popular band at the time, all right? But today, the edge has a totally different meaning, right? We tend to think of it as distributed computing. And distributed computing back in the 70s was a teletype. It was a brown machine, about 3/4 of the size of this lectern, okay? Had a roll of tape, a roll of paper tape, and an acoustic modem on the back. And that acoustic modem, it talked to a mainframe at 110 baud. 110 baud, folks, is about a character per second, okay? Very slow. So today, distributed computing has a whole different meaning, okay? Distributed computing is the ability to process data close to its point of creation, okay? So in the mid-1980s, we had, I'm going to talk a little bit about cycles here. So in the 70s, we started with that distributed approach. You were talking to a mainframe. In the 80s, we came out with the IBM PC, okay? The IBM PC led to servers, and then we had the client-server architecture of computing, which was the first generation of distributed computing that was not talking to a mainframe. Distributed computing was talking to a server that was in your closet down the hall. It was a file server. It was an email server, okay? From there, we've evolved into the model that has become prevalent today, cloud computing. And what is cloud computing but a giant centralized system, once again, of computing, and we all access that central computer, okay? Edge computing is the pendulum swinging the other way and putting compute power out into the field again at a different level, and a different intensity level, okay? So let's go next slide. So Gartner recently said that around 10% of enterprise-generated data is created and processed outside of a traditional centralized data center or cloud. In the next 4 years, that figure is expected to grow by 50%. So I think that says the why of edge, okay? That tells you that we are going to be growing in a rapid fashion. Now that's a bit of an eye chart. The next piece is the Gartner hype cycle, okay? Gartner talks a lot about their hype cycle. What is it? Well, the hype cycle is just a way of capturing trends and topics in one place that affect the compute industry. This comes out of their data center conference that takes place from July through December around the globe. And the items that I've highlighted, edge computing, smart workspace, 5G, these are all going to be very data-intensive activities that are coming out. But if you look, their time frames, everything is in 2 to 5 to 10 year increments. Okay? So none of this is going to happen today in high volume. There's still a lot of things that are going to go and grow and drive that activity that will take us to the edge. Okay? So the next screen, the question is going to be for everybody what our perception of edge is. From my perspective, edge is the things that are near me and things that are on me, and eventually, and I hope not to live to see this, the things that are in me. Okay? Edge computing is going to be the infrastructure that supports those three categories: near me, on me, in me. Near me is all those things that are terminals, are kiosks, electronic displays, beacons, augmented reality points. How many of you guys have a kid that played Pokemon Go in the past couple of years, right? It was a big craze. You had to hold your phone up. You went to different places, and you could see different things based on where you were. It was geolocating. Okay? Imagine doing that full time in your everyday life. What if you could see what the cost of something was, or who owned something, or what was transacting inside the building? If you could know that at all times as you walk through a city, how different would your life be? Okay? So edge computing, when I say last mile or the only mile, if you can find a way to avoid having to go all the way to the cloud to handle the majority of your processing needs, your storage needs, your content delivery needs, then you have avoided log jamming the data pipes that lead to the cloud. Okay? Why do we want to avoid that? Well, if you look at the confluence of all of the different data sources of creation and the points of consumption that will be coming, I think you'll begin to understand we're not going to be able to put in fiber fast enough to accommodate all of that traffic to go to the cloud. Okay? Consequently, we're going to need some way of condensing and prioritizing and delivering traffic at a more localized level. And that is the purpose of edge computing, or the mission that it is intended to fulfill. Okay? So this is the being processed outside of a traditional data center. What are we thinking of? Well, there's autonomous vehicles. There are autonomous sensor networks. People are talking about smart cities where you're going to have intelligent light poles, where that light pole can tell you who's walked by, when they walked by, what they were doing when they walked by on their phone. Is the parking space adjacent to the lamp post available? Is there a runoff problem in the gutter? Is there a need for a map so that people can see where they're going? And so on, and so on, and so forth. Okay? We believe that other points of use and consumption and creation will be self-flying planes, unmanned drones, sensors of all sorts, okay, whether that's temperature, whether that's humidity, whether that's air quality. But as we continue to grow the availability of those types of products, they will find a home eventually. As the price point comes down, more people will adopt them. Okay? So what do data center professionals like yourselves need to be on the lookout for as the edge begins to show itself, as the need grows, okay? I would say that don't be concerned. Just as the MC was introducing and so forth, we talked briefly about the fact that much of the infrastructure that you're going to need for powering the edge, it already exists, okay? If you think about where we're going to deploy edge-type locations, many of those are already going to have power, network, some degree of sensors, some degree of security, some degree of physical access. You've heard during the day here many different people speak of deploying infrastructure at cell tower locations or at other locations throughout a city. So I will get into a little bit more of what that's going to look like, but basically, edge locations are places that we're already familiar with, all right? Co-location providers, cell towers, cable and telco huts, homes, offices, industrial parks, factories, vehicles, highways, things that are already around you, things that already have a degree of infrastructure support, okay? So, like the mantra of the real estate business, location, 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 edge is going to be all about locations, all right? A good example of somebody that is already taking advantage of and was kind of leading the charge into the space of edge deployments is Akamai. Now, I have no commercial ties to Akamai, but I want to cite the fact that Akamai has let it be known that they have access to more than 1,700 different networks that overlay the internet, and that they have more than 2,300 physical locations spread around the globe. What does Akamai do? Well, they're a content delivery network, much like the application that the gentleman back here was pointing out. Akamai has led the way in showing us the why, the what, and the how of edge deployments. I expect that more and more we will see other companies doing much the same. I mean, why would you have Google pursuing Project Loon, where they want to offer data service from a balloon to remote areas that may not have the same kind of coverage, but they would still have needs for that access? Or why would we have so many companies saying that they will be out with access points of one sort or another? So I'm going to cite another example. There is a gentleman here in the audience from Vapor.io. I do want to Legrand is not affiliated with the following partnerships, but I will talk briefly about what I know about those. Vapor represents one of the other newer implementations of an edge computing approach. They've announced partnerships with a number of different companies. One of them is Crown Castle, who's here. Crown Castle is one of the largest cell tower real estate companies on the planet. The other one is American Tower. And what Vapor has done is they have partnered with these companies to deploy infrastructure and deploy assets at cell tower locations. Now, what you see pictured, this is what would be referred to in the industry as a macro cell. All right, that's going to be a high power availability location. But there's already radios running. There may be generators already on site. There will be backup already on site, okay? And what they are bringing is the compute infrastructure to be able to process data and do a lot of original content access, storage, processing in that location. So they are supplementing the network. They'll be there. Hanger is a drone manufacturer and operator, and it's my understanding that they have also engaged with Vapor to provide delivery services from this point. Now, I don't know if it's going to be delivery of surveillance or if it's going to be delivery of product, but they want to ride along on that same infrastructure, and they've got a degree of cachet at the moment, shall we say. So let's talk about what 5G brings to the table and why it's part of the conversation for edge computing. So a macro cell has radio coverage out to about 1 kilometer. Macro cells run in the hundreds to thousands of watts in order to operate. Okay? A microcell has a propagation distance of about 500 meters, and it's under 1 kilowatt for radio. A picocell has a range of about 100 meters, and a femtocell about 30 meters. Why do I bring that up? Well, with 5G radio, the free air propagation at 30 meters means that something inside this room radiating a signal will completely attenuate by the time it leaves the room, just passing through the air. So its propagation distance is very short. In that circumstance, that cell still needs backhaul, it still needs power, it still needs a degree of security. Well, that looks a lot like the existing Wi-Fi coverage that's out. So where Wi-Fi sits is where you're also going to wind up putting a femtocell when it's inside of a building, because femtocells do not propagate through the walls at all, okay, at the frequencies of 5G radio. What we're talking about, 5G radio will be running in the range of 50 to 60 gigahertz. It's millimeter wave. One wavelength is about that big. And it's what is used in the security apparatus at the airports, but it will also be what we are relying on to provide enough spectrum to give enough bandwidth to be able to deliver all the instantaneous access that millions and millions of new users will require in order to have the content, to have the gaming, to have the support that they need for their driverless vehicles and so on. So what do you need to be looking out for in that case? You've decided you're going to deploy to the edge. You're going to be part of that infrastructure that's out there. What do you need to look for? Well, you want to make sure that you maintain your uptime, that you maintain your physical security, that you have the ability to perform a degree of remote maintenance of what you have deployed, and you want to be able to be flexible enough to operate in any environment, whether that's an AC environment or a DC environment. So you need to work with partners that can provide support for both. You're also going to want to avoid power capacity issues. So you're going to need some tools to help you monitor and plan for what you need to have in the power capacity and cooling capacity and all of the basics that your current data centers already do. You're just distributing that same need, right? You already do this today. There's no rocket science involved in that. You also want to avoid critical temperatures. You want to keep your equipment self-regulating to the best of its ability. You want to automate and have it control itself whenever possible. But in the event that a device suffers a random stoppage, your first line of defense should be to execute a remote reset, right? In that circumstance, you want to be able to send a command either through IP or through some out-of-band access method to remotely reset that hardware. And you want the system to have a graceful way of shutting itself down in the event that conditions dictate. So for example, the grid went down, your genset is running out of gas, then you need to execute a graceful shutdown so that you have a known state in all of the hardware that's deployed. You also want to maintain a degree of security, both physical and logical. So you will need to, just as you do today, practice good data center practice. That is, utilize secure protocols, utilize encryption, make sure that you authenticate your users, that you disable unsecure services. So if you're still using SNMP v1, or if you're still using some of the older versions of SSH and so forth, you need to update. You also need to exercise good discretion in granting permissions. You want to set them at a very granular level. Don't give unauthorized users an open doorway to step in because you forgot to change the default password. And for those authorized users, you want to minimize the attack surface that they present. You want to make sure that those users are restricted to only doing what they are allowed to do. You also want to incorporate a degree of sensors into your edge location. You want to know what is the temperature, what is the humidity. Has somebody opened the door? Can I put in a remote access door so that they have to come to me to be able to get in? Those types of approaches are very common and good practice, just like being inside of a colo. You may have a setup that allows you to use remote hands in that colo, right? And you may still exercise control at the rack level to say, yes, Mr. Remote Hand Service, you can come in, but you cannot get into my rack until you call me and tell me that you're in front of it, and I will open the door. Same sort of thing for edge deployments. You're going to want that level of security. You're also going to want to be able to scale. Just like those of you that have stood up a data center of hundreds or thousands of racks at a time, your edge deployments may take that same sort of scale. In fact, it may be even larger in some cases. And when you do that, you're going to want to be able to quickly configure, provision, and stand up that infrastructure as well. To do that, you're going to want to be able to discover automatically what you've stood up, and you're going to want it to self-configure as quickly as possible. Now picture thousands of pieces of equipment out in the field in thousands of locations. The last thing you're going to want to do is to go out and have to physically touch every system every time there's a new firmware update. So just like your existing 4G infrastructure, just like your existing data centers where you're trying to have one tech support 25,000 machines, you're going to want to have those devices either pull the firmware or you have a tool from which you control a push to all of those devices in the field. Sounds familiar, right? It's just distributed. All you've done is taken that data center and replicated it at a smaller scale, but all of the things that you currently do in operating your data centers will be the same thing that you need to do at your edge deployments. Additionally, you're going to want some out-of-band access. In the event that the device that locks up is your network controller, you need a secondary path to gain access to your devices in the field. We recommend a KVM. Mixed power environments. They present an opportunity and a challenge. When you can find it, look for a single management interface, a single tool that will let you look into both environments. There are very few manufacturers that will let you do that. Your alternative is to deploy a DSIM tool or some other high-level management tool that will let you obscure the underlying hardware interfaces and work with one common interface at a higher level. We offer solutions for both. You also need to consider a variety of form factors. You're going to want to know that you can get what you need in the form that you need it in a short lead time and have somebody that will stand behind their product offering. So I'm going to summarize. Edge is real, but it's not what you think. The power density behind edge deployments is going to vary anywhere from watts that can be supported by power over Ethernet to kilowatts, in which case that's architecture that's already in your wheelhouse. You already know how to deal with those. Uptime, of course, remains crucial. Latency in an edge deployment is the death knell, however. If you introduce latency, if you have a problem communicating, getting data into or out of your edge, then you've done no one any good. Okay? Edge deployments will require greater monitoring and security needs just because of the number of places where you will be located. But it's no different than what you currently do with your data center. You want to have access control, physical and logical. And finally, again, flexibility. You want to work with vendors and you want to work with partners that have a high degree of flexibility in both power capacity, form factor, product availability, scalability, customization. All right? That's it. It's easy. Powering the edge is not rocket science. Any questions? Yes?
Yeah, so in your slide you use 6.7 kW per rack. Will you assume that there's multiple racks? What would be an average size for the edge, say, for microwave cleaner?
So that was a quote from Bill Clayman, and that was part of a prior webinar that was done on the Raritan side of our house. Bill's data, as I understand it, comes from looking at a number of different edge type configurations. Vapor and Crown Castle, what they've announced is a 6-rack location with 150 kilowatts, okay? Roughly 30 kilowatts a rack. That's based on an open 19 type of architecture. And that's very power dense because they expect to do some heavy duty compute and storage in those racks. Other locations may not be so much. It may be down in the 1 kilowatt range, which means you just plug into a NEMA outlet and you're maybe controlling or monitoring 2 to 3 devices that are plugged in. And so in that case, you know, the power level is far below that 6.7 average. Does that answer your question?
Yeah, I'm just curious.
Sure. So, other questions? Easy. All right, well, thanks everyone. We appreciate you coming out today. Thanks for your time. And